Hello everyone, I am Simran Kaur, your science teacher from Shiv Jyoti Educational Group, and today we will start a very interesting topic of science, which is force and pressure. We have divided this chapter into two parts. In first part, we will talk about force only. Like force, a push or a pull. Forces are due to an interaction, effects of force and kinds of force. In the second part, we will cover about pressure, that what is pressure and pressure exerted by fluids like liquids and gases, and what is atmospheric pressure. Force, a push or pull. You know that there are two types of things, living things and non-living things. Living things can move by themselves, means they do not need any external energy, external force, but in case of non-living things, they do not have feet or they do not have legs or arms, they cannot travel from one place to another. Like here, this is a boy, he is walking with the help of his legs. Like this is an animal and he is jumping by using his legs and arms. But in case of non-living things, some actions are required to be done, and those actions can be opening, like for opening any jar or your water bottle, what you do? You apply an external action, that force, like this kid, he is opening the door of a car, means he is applying an action. For moving this football, what he is doing? This kid is kicking this ball. Like to lift up your school bags or any bag, what you do? Again, you need some action. Here, to pull any drawer, to open a drawer, what you do? Again, some action is required. So, all these actions, this pushing or pulling is known as force. So, push or pull of an object is called a force. The direction in which an object is pushed or pulled is called the direction of the force. Here, these people are pushing this van. Okay, they are providing an external action, they are applying some action. So, they are pushing the van in which direction? In right direction. So, the motion of this van will be in which direction? In the same direction in which force is applied, means the van will start moving in the right direction. Here, this ice cream vendor, he is pulling his cart in which direction? Again, in right direction. So, this cart started moving in the same direction. So, the direction of motion will be in which direction? In which we are applying force. Then forces are due to an interaction. To apply force, two objects are required and their interaction is required. So, interaction of one object with another object results in a force between the two objects. Look here, this is a boy and this is a box. This boy is doing nothing, means he is not interacting with this box, he is not pushing it or pulling it. So, is there any force? You can see, is there any motion in the box? No, there is no motion. But in this case, this boy is pushing that box. So, when he is pushing, means he is applying force, and you can see this box started moving. So, forces are always due to an interaction between objects. Now, force is represented by F and arrow over it, like you have known few physical quantities like kilometer, that is we use to measure distances. So, km is what? The unit of distance, like seconds we use for time, s. So, similarly for force we use F. Now class, there are two types of quantities, students, there are two types of quantities, scalar quantity and vector quantity. In scalar quantity, we talk about only magnitude, okay? But in case of vector quantity, an example is force. Force is a vector quantity, means it has magnitude and it has direction. It has both magnitude and direction. SI unit of force is Newton. Like SI unit of time, we know that it is second. So, SI unit of force is Newton. And it is, the symbol for Newton is N, simply capital N. Then in CGS system means it is a metric system, centimeter, gram and second. In that system, we represent force, we write force in Dan. The unit in CGS system is Dan. And the relation between Newton and Dan is 1 Newton is equal to 10 raised to the power 5 Dan. Like what is the relation between kilometer and meter? That 1 kilometer is equal to 1000 meter. Similarly, 1 Newton is equal to 10 raised to the power 5 Dan. Now, point to be remembered that force does not always make an object move. Now, you will say that, ma'am, I am pushing the wall of my home and it is not moving, but I am applying force. Why so? Because that wall is not capable of moving from that position to another. So, force does not always make an object move. Like this man, he is pushing this box, but it is not moving. But there is force, but there is no motion. Understood? Okay, now let's explore forces. Suppose there is a very heavy box lying on the floor in the middle of the room and your mother asked you to remove that box from that position. So you applied force, you applied your energy, push it away. But you were not capable of pushing it away because it was so heavy. So you called your brother or your friend to push it away. So now let's suppose this white t-shirt boy is you. You are applying force with magnitude F. Okay. Now you called your brother and he is also applying force F in the same direction. So what will be the net force? What will be the resultant force? Now you too will be able to move that box. So we can say that when force is applied in same direction, forces add to one another. When you apply force in the same direction, like you two are applying force in that right direction, so the box will move in right direction and the magnitude of force will add up. So you were also applying F force and your friend was also applying force F. So when you will add it up, it will be 2F. But in case of in other situations, suppose you started fighting, you and your brother. You want to move it in right direction, but your brother want to move it in left direction. So what you did? You started applying in opposite direction. You started applying force in opposite direction. You are applying F force from this direction and your friend or brother is applying force F from this direction. So in that case, the net product, the net force will be the difference of these two forces. When force is applied in opposite direction, net force is the difference between the two forces. Let's say the magnitude of forces are same. You are also applying F force and your brother is also applying F force. So net force will be F minus F, that will be 0, and which means that there will be no movement in the box. It will lie there only. Okay, you have seen that phenomena in the game tug of war. Almost everyone has played this game. So which team wins? The team which applies more force. Like this is team A and this is team B. Okay, these three children are also applying force. What are they doing? They are pulling this rope. Okay, and these three kids are also pulling the rope in opposite direction. These children are pulling rope in which direction? In left direction, and these three kids are pulling in right direction. So the team which will apply more force will win. You know the rule of this game, not a new to you. So the team applying more force would win because the direction of net force will be towards winning team. Now let's talk about effects of force. Force brings about the following effects. First is, a force can change the state of motion. State of motion means either any object is moving or it is at rest. So force can change the state of motion. And force can also change the shape of an object. Let's see how. How force can change the state of motion. Force applied on an object may change its speed. How? Look here. You have seen football matches. So what is the role of goalkeeper? He tries to stop the another team to goal. So the opposite team kicked the football, and this goalkeeper, what he is doing in this picture, he is stopping that ball. So he is applying force in opposite direction. So when we apply force in opposite direction, the speed of an object decreases. You can see earlier the ball was coming with greater speed, but as soon as this goalkeeper applied force in opposite direction, the ball, the motion, the speed of the ball decreases, and he saved the goal of their team. But in case of when the force is applied in same direction, the speed of object increases. You can take example of car, a moving car. When you accelerate your car, then what happens? You are applying force in the same direction. So the speed of car keeps on increasing. But in case of when you apply brakes, what happens? You are applying force in opposite direction. So in that case, speed of your car decreases. Force also changes the direction of moving object. In cricket match, you have seen the ball was coming from this side. As soon as this batsman hits the ball goes in somewhat different direction. So that is what? Force also changes the direction of moving object. Very simple chapter and very interesting. Now second, force can change the shape of an object. How? You have seen your mother kneading the dough. What she does? She applies force to knead. So there you can see there is change in shape. You can convert this dough into thin chapatis or any other another shape, or you can see clay. You can mold it into varieties of shapes by applying force. Here you can see when we stretch the rubber band, when we apply force using our fingers, what we are doing? We are changing the shape of this rubber band. Now let's talk about kinds of forces, types of forces. There are two types of forces, contact force and non-contact force. Contact force, as the name indicates, contact means there is contact between two objects, means there is physical contact, means they are touching with each other, they are touching to each other. So contact force acts only when objects are in physical contact with each other and bring about necessary changes. This is a stylus, this is a pointer. If I will not touch it, then can I operate it? No, because there is no contact between my fingers and this pointer. So in contact force, physical contact is must. It is of following types: muscular force, mechanical force and frictional force. Muscular force, it is related to muscles. So when you apply force using your muscles, then that force is known as muscular force. So muscular force is the force that results due to the action of muscles of humans or animals, means we are using our muscles. Like which force I am applying right now? This is muscular force. Okay, I am using I am picking it up because of the action of my muscles. It is applied using parts of the body like arms and legs. Like this boy is lifting these dumbbells using his muscles. Like this boy is lifting up this bucket, again by which force? By muscular force. Here this horse is pulling this cart by using his muscles, that is muscular force. Now second type of contact force is mechanical force. Here we use the power of machines to apply force. So a force that involves contact with another object and which produces a change in state of rest or motion is called mechanical force. Means we can bring moving objects to rest and we can move the object at rest into motion. Here you can see by applying mechanical force we can drive a car, and here this flowing water is used to rotate these turbine. So which force is applying? We are applying mechanical force and we are generating here electricity. This is hydroelectricity. The next type of contact force is frictional force. Frictional force refers to the force generated by two surfaces that contacts and slide against each other. Frictional force comes into act when two objects are sliding over each other or are moving. And here, see this. The applied force is in right direction. Always remember, frictional force will be against the applied force. If you are applying force in right direction, then frictional force will be in the left direction. So you can imagine the situation when you walk. When you walk, in which direction you are applying force? You are applying force in the backward direction, because then only frictional force will come into act and it will be applied in the opposite direction. So when you are applying force in back direction, so due to frictional force, it is acting in the left direction and you are able to walk on the floor. During cycling, when you stop paddling, what happens? Your cycle comes to rest. Why? Because of the frictional force between the wheels of this cycle and the road. Now let's talk about non-contact forces. Non-contact means no physical contact is required. Non-contact forces do not involve physical contact between the bodies on which they act. So how can we apply that non-contact force? It acts through the space between them. The space between two objects is required only. No physical contact, no touching is required. Types of non-contact forces are magnetic force, electrostatic force, gravitational force and nuclear force. Magnetic force, you all have played with magnets, so you all know the phenomena of attraction and repulsion. So the force which magnet exerts on magnetic objects without being in contact with it. You know that when you bring a magnet near any metallic objects, do you touch it with that object? No, but magnet automatically attracts that magnetic object. So it is acting through the space between magnet and that object. Here you can see the phenomena of attraction. And in case of repulsion, watch it clearly, means these two magnets are not touching with each other, but you can see the repulsive force when you bring the same poles near to each other. Then is electrostatic force, the force exerted by charged body on another charged or uncharged body. Look, there are two types of charges, positive and negative charge. Opposite charges always attract each other. Here you can see positive and negative. Opposite charges always attract, whereas similar charges always repel. Positive and positive, it will repel. Negative and negative will repel each other. Where you can see this force? When you rub the comb over your hair, oiled hair, and bring that comb near the small pieces of paper, you can see there is attraction between this comb and this uncharged small pieces of paper. Why? Is it a magnet, this comb? No, this is not a magnet. So why it is attracting these small pieces of paper? Because of electrostatic force. You can see the same phenomena in this case also. When you rub balloon against your hair, you can stick it to the wall. So is your wall sticky? No. But why it is sticking to the wall? Because of electrostatic force. Or when you bring this charged balloon near your hair, it will attract your hair. So it shows what type of force? Electrostatic force. We can generate it by rubbing the surfaces. The next is gravitational force. Again, you have heard of this gravity, gravitational force. So what is gravitational force? Look, in the universe, all objects have some mass. So according to this force, objects which have mass, they attract each other. Okay? So the gravitational force is a force that attracts any two objects with mass. You have seen this phenomena that when apple falls from the tree, it always comes to the earth's surface. Why it is so? Because earth, it is falling on earth. Earth has huge mass. An apple also have a mass, but comparatively to earth, it is negligible. So who has more power, earth or that apple? Obviously earth. So that's why apple is getting attracted towards the earth's surface. And gravitational force is always attractive because it always tries to pull masses together and it never pushes them apart. It is always attractive, it is not repulsive, it cannot repel the object. Where else you can see this phenomena? This is our earth and this is moon. You know that moon revolve around our earth. Why it stays on its position? Because of the gravitational force between earth and moon. Nuclear force. You know that atoms contain electrons, protons and neutrons. So the nuclear force is a force that acts between the protons and neutrons of atoms. Here is a figure of atom. It is because of this force that the particles stay together. Because of nuclear force, particles stay together. They do not fall apart. So that was all about forces. I hope you understood what is force, the types of force and the effects of force. Thank you for watching.